Hi everyone, we hope you did great on your calculus integral exam. We are group 15 and let's learn more about integral. Again, in engineering and physics, integral can be used to calculate the accurate and precise location of the centroid. Now, here is our big question for you. Imagine that you are an asteroid. Your goal is to hit the Earth at the position that will impact all the locations in Vietnam from the furthest province in the north to the south. To answer this question, you should find the centroid of Vietnam. More about that at the end of this video. Now, let's begin with simple question. Can you guess the centroid of the following shape? The pizza, the donut, the square pizza, and the triangle donut. If you want more time to think about the answer, please pause the video. And here is our answers. If you think the centroid located at the center of each shape, you are absolutely correct. The centroid of symmetric shape will always located at the central point. For definition, the centroid is the geometric center of a 2D shape where there is an equal amount to an area to the left and right, above and below that point. To find the centroid position, you have to find the C point that located at x bar and y bar coordinate. The x bar is the average x coordinate of that area, and that's the same for y bar. Knowing the definition of the centroid, can you predict the centroid location of the following shape? The letter J in Dr. Janet's name, the island, the letter F, and the whatever shape. Here is our answer. J might be accurate, but might not be precise. Since the shapes are asymmetric, the centroid location are harder to predict. Then how can we find the exact location of the centroid? Here's our guide for you.
Okay, so I will be leading you guys through how to find the centroid coordinates with integrals. To find an average value of a sequence of number, we sum up all of the values and divide it to the number of values. Similarly, for a 2D surface area, if we treat the shape as a collection of small rectangles, we can replace the sum with the first area moment integral. Now, what is the first area moment integral? It is the sum of the small rectangles times the distance to the reference axis in the notation x times dA. In this function, the reference axis is the x-axis. Once we have replaced that, our formula to calculate the x bar value should look like x bar equals integral from a to b, x times dA divided by a. In the x bar formula, dA can be rewritten as fx times dx, and fx is the height of the rectangle at any given point x. For the y bar coordinate, dA here is similar to the equation in the last slide and can be rewritten as fy times dy, which is the width of the rectangle at any given y value. In this example, we will investigate the centroid of the shaded area enclosed by the function fx and the x-axis in the range between 1 and 4. Before getting into the coordinate calculations, there are a few steps that we need to prepare. Remember from the formulae, we need to find the total area of the shaded region. So the first step is to calculate the integral of the provided function from 1 to 4. We get a result of 18. The next step is to rewrite the function. We were provided y as a function of x, and we need to get x as a function of y. This is very important as we will need this to calculate the y coordinate. However, please be noted that this can vary between problems. There are some functions that we cannot rewrite to get x as a function of y. Once we have done that, we also have to find the range of the y in the shaded region. Here it is between 1.5 and 12. Just simply plug the two x values into the function to find the corresponding y. With all of the preparation done, we can proceed to evaluate the centroid's coordinates. For the x coordinate, the integral that we need to evaluate is the first area moment integral. Remember that when evaluating the x coordinate, the range for the variable x is from 1 to 4. Once we evaluate it, the result is 2.9, around 2.9. Similarly, for the y coordinate, the first area moment integral is now y times fy dy. The range of the integral is also changed for the variable y, which is now from 1.5 to 12. Once we evaluate it, the result is around 12.1. And there it is. Using the integrals, we have identified the centroid of a 2D surface.
For our question at the beginning, can you guess where is it? Here's our approach. To calculate the centroid of Vietnam territory, we will use integration. Our first step will be find every function that creates Vietnam borders. Second, we will evaluate the integral of the function to have the area of Vietnam. Third, we will evaluate the x-bar and the y-bar to locate the centroid. And our final answer is Savannakhet province in Laos. Congratulations to whom predict the correct answer. That is the end of our presentation. We would like to thank Dr. Janet for your instruction and thank you for watching.